Hello and welcome. Please put your hands together for your MC for the day, Tim Rastigar.
Welcome back, everyone. Actually, I'm the one that just came back. I've been over there at the exhibit hall. I hope you do the same. Lots of cool exhibitors out there, including Trailhead, but that's it for my shameless plug. I'm actually here to introduce our panel, if you will, and Jay Larsen from the Idaho Technology Council. Right here it says that he doesn't need an intro, but I should give him one anyways. And I'm not going to read this intro because I have my own version of it. In a roundabout way, Jay is responsible for me being here today. I met Jay, I think it was 12 years ago when I was working at PKG, and he was, at that point, one of the first, what I call, ecosystem warriors. He was going around the state and trying to build a technology ecosystem to help Idaho companies thrive. And so, blame it on him. That's the reason I'm at Trailhead. Welcome on stage, Jay, and you're going to introduce the panelists, so let's go.
So thank you guys very much for being here. This is an opportunity for us through IMTECH. We, the Idaho Technology Council, and we have a Spark series, and so we're doing this in conjunction with IMTECH, and we really have a tremendous opportunity to talk about artificial intelligence today. It's one of the coolest things around. Artificial intelligence really quickly started in about the mid-1950s, where it came out of Dartmouth and all this other stuff, but it really came to the forefront about the 70s. And at that point, there was a person who was really got a Pulitzer Prize winner, and at about 1970, he said in about 20 years, this person was out of University of Chicago, worked with some of the top areas. Dr. Simon is his name, and he basically said in 20 years, we are going to have the point where all machines are going to be able to do all the things that humans can do. So now 20 years went by, didn't happen, right? But we have the chance now to be able to talk with three really leading artificial intelligence leaders at three companies. So I'm going to introduce them right now. James Bullock, please come. James came all the way from Louisiana. I don't know why I came to Illinois. So let's hear it for James. James with Boise Cascade. Dan Siddall. Dan is with, came all the way across the quad. He's with Clearwater Analytics. Thanks, Dan. And also Josh Johnston. He came all the way from Kount, an Equifax company. So let's hear it for both of those, all three of these. Thank you. Take a seat, guys. So as we start this out, you guys, one of the biggest things I'm going to tell you about artificial intelligence. I was in North Idaho 12 years ago. And when I was there, a person moved up there. I'm not going to tell you his name, but he moved up there from California. And his dad was part of the Apollo mission, and he helped design the lunar module that landed on the moon. This guy's brilliant. Aviation's all this stuff, and artificial intelligence is big. The Department of Defense came to him and he said, okay, we need you to be able to build a robot that will go out into the field of battle and be able to perform triage on injured warriors. And the guy said, okay, let's talk about that. So they got in a meeting, he goes, why are you asking me to be able to build a robot that can go out and do triage on warriors, humans that are wounded in battle? Why don't you just make a smart warrior that can go out and battle? And don't sit there and bypass it. So that was what he said 12 years ago to the Department of Defense. Put that as a side note, because that's not what we're going to talk about today. We're going to talk about really where artificial intelligence is in three really awesome companies that provide a lot of assets and resources to the state of Idaho and the people who live here. So let's just go around right now. Josh, we're going to start first with you. Talk a little bit about, all three will do this, about where artificial intelligence is and what it does for each one of your companies, Kount, Clearwater, and then Boise Cascade. So,
sure. Actually, Jay, I really like that story. That resonates with me. My background is from in robotics, so I spent about a decade doing mostly military research, explosive ordnance disposal robotics, and self-driving cars and things like that. And the reason I got out of that field is I think that we were very locked into that type of thinking. We were thinking about robots, which are by definition embodied, And when you're in robotics, you think of robotic solutions to problems. We think of things like, let's build a robot that'll do surveillance of this building when it's empty, so that we know if somebody comes in and breaks in. So we'll build robots that drive around and look for things. Why? We can put cameras at the entry points of this building and look at the hallways and all of that. And it'll be cheaper than building something that drives around. So I think that view from the history of where AI has come from, we spent so much time as a field in the space of robotics, which is like ridiculously fun, don't get me wrong. But the reason I got out of that field was actually seeing that the things that we were developing and the things that we were applying, there's a lot of opportunities to do that outside of what we think of as like going out into the field and doing it there. So I've been excited to see artificial intelligence come into business. I started at Kount about 6 years ago, and we protect digital interactions. So our background really comes from credit card fraud for e-commerce, and we've grown into more things since then. But this is a problem where you have to go and collect a tremendous amount of data, look for the patterns, look for the structure that's in that data and the outcomes that you get, and try to make better outcomes and protect all of us in here from having our identities stolen. Again, there's no robotics in there, but the techniques that we use come from the exact same academic tradition, just now applied without that embodiment. We got bought by Equifax just a little more than a year ago, and this is, I think, that wasn't only a validation of this great ecosystem in Boise, and there's been a lot of really nice exits for tech companies here in Boise, which has been great to see. But also, I think it shows how companies like Equifax, which is a 120-something-year-old credit bureau, recognize that this technology is, you have to invest in it. It's part of moving forward. It's table stakes.
Yeah.
And interestingly, as we talk about it really quickly with what you have, you went from having millions of points of information that you had to sit there and go through within milliseconds to billions, right? I mean, it's like...
Well, we had billions already, but we have more billions now.
You have more billions.
More billions.
So what artificial intelligence does for you and Kount and Equifax is pretty amazing, right?
Yeah, I would say, the kind of future views saying you're going to do everything a person does in 20 years. I think what makes those kind of silly dooms to failure is that I can't do everything a person can do, right? Everybody in this room is better than me at something. Okay. The real question here is, nowadays the technology has moved into places where the really interesting stuff is where it's superhuman. So fraud analysts can do things that our algorithms can't do. But our algorithms can go through just tremendous amounts more data than a person could ever view and ever see. So that's where I think a lot of the value proposition. We're not trying to replace humans. We're trying to lean into these places where you get that advantage. And certainly the scope of data that's available, with modern compute is just crazy.
Yeah, exponentially, you can do so much more with what you're able to do because of that. Thanks so much, Josh. Dan, go ahead and talk about that in Clearwater.
Well, so first I started out at HP. We were doing part prediction failure stuff there, and then I moved over to Clearwater, and it's a completely different area where we're not using AI to predict, what this thing's going to fail with a bunch of data. We're taking financial data from, thousands of clients. We're trying to put all this data from different areas into this set of reports and calculations we do for a client. Just trying to get all of those different data sources into the same format is a daunting task. And there's places for AI in there, or you get complicated text documents that have interesting pieces scattered through the document, and this relates to something a paragraph down, or this in this sentence relates over here, and doing natural language processing to say, okay, here's the data and here's the things that relate to it. Oh, well, I have an interest rate for a bond. And then you've got to find, okay, when does it pay? So somewhere in this document, there's also a thing that says, well, it pays on the first of the month or first of the quarter. It's trying to find all those pieces in a text document and link those together. And then what if the transactions don't line up? Let's say, for example, that I bought a bond. It pays 5% interest. It pays first of the month or first of the quarter. Well, here it is the 5th of the month on the first of the quarter, and I don't have my money. What happened? We need to go look for what happened, why didn't it get paid? Is this a typical thing? Is this delayed? So there's a lot of opportunity for AI in there to resolve any interactions, anything that's missed. I mean, for example, if you bought 100 shares of it and somebody typed in 10, the decimal point got switched. Somebody's got to find that and reconcile that problem. And you can have humans do it. You're going to need a lot of them, depending on the volume of data that you're pulling in, number of accounts. Or you can start using computers to do the tasks that you would have tens or hundreds of people doing.
So efficiency is really coming into play.
It's what he was talking about. It's the volume of data where you're really seeing the value of AI is there's not a single human that's going to look through 1 billion transactions in a day, right? It's the same here that we've got thousands of transactions that need to be looked at to evaluate. There's going to be a lot of humans.
Yeah, so it expands opportunities, right, that we have. So, well, now we get the opportunity to talk to James, again, Louisiana. And what's so good about James, it's a little bit different, is that he does this all in more of a manufacturing setting.
Yeah,
So
that's
James,
right.
Talk to us about this. And Todd, tell us about what was it your mom who said something? It's kind of interesting.
Yeah. So before I begin, I'll say that a lot of times my head will outrun my mouth and I'll stammer, so just be patient with me, right? But yeah, so when we made the post online about it, my grandma, I don't think she really knew that I was going to be here. She knows I'm working in AI, but it's not my only job. And so she made this big post about AI and the devil and all kind of things. It was it's like, wait a minute, Grandma, that's me doing that.
Yeah, I like that.
Yeah, so there's a lot of different perceptions about AI, but we'll talk about that in a bit. So for me, I didn't start like these guys did. I started in manufacturing. I grew up in manufacturing, so I started as a broom engineer. No, I'm just picking. I was sweeping the floor, right?
That's a broom engineer. Yeah, I like that.
And so after a year or so of me telling everybody how to run the plant, they decided to let me try to run the plant. And so I worked through a number of jobs and was promoted over and over again. But through this process, my background is in math and computer science. But I went into manufacturing to make more money, quite honestly. So as I moved through the company, though, I saw this huge time to value proposition with machine learning in that there were so many things that I knew that we could do so much faster. I mean, there were people out there watching these machines. They make a change, they wait, they see what happens, they make a change, they wait. Where with AI, you just program it to do it and it solves the problem and loops through. And there's a number of examples like that. And so that's one part. The other part is just on the business side. In our plants today, there are teams that are split apart. So every process is separated, it's decoupled. And we do that strategically so that if we have a downtime event, we don't shut the whole plant down. But the side effect of that is nobody knows what the other teams are doing. Yeah. Right? And so from the start of a plant all the way through, everybody is looking at their opportunity. The beauty of AI and what our company is using it for today is now we can tie everything together so that the team at the front of the process, when they're evaluating their opportunity, they see how it's affecting the people downstream.
So you really, if you look at what you're doing in your plants, because you were over several plants that are located outside of the Louisiana area and around Atlanta and Georgia and stuff like that, right?
That's right, yes, sir.
So if you look at that, what kind of efficiencies are you gaining through some of the work that through AI is doing?
Yeah, so typically on a reinforced learning solution on a machine, so we basically tell the program to win the game. We say, hey, stay in the safety parameters, stay in the quality parameters, but the game is run more. And typically we're seeing 5 to 10% improvement per machine center, and in a business like ours where every hour is thousands of dollars, it is adding up in a major way.
Wow, that's great. So thanks. Josh, so you came from autonomous driving vehicles where you kind of started your AI experience, right?
Yeah.
And then you see this deal that you were just talking about, how you're doing this now through Kount and fraud detection and all this other type of stuff, identifying the bad guys on the planet too, probably. If you bring this intersection, talk about how AI really, where you think it is today and where it might be into the future with what you're doing.
Sure. So the first thing we always have to do when we talk about this stuff is some definitions, because everybody has their own definitions, and I don't think most people slow down and stop to really think about what they mean when they use these terms. So artificial intelligence is a quality of a machine. It describes a characteristic where a machine exercises something that looks like human judgment. Interesting thing about that to me is that it's constantly changing then, the definition of artificial intelligence. So I took a class when I was doing my master's degree at Carnegie Mellon. There was a class on artificial intelligence, and I took that class in 2005, which is the last year that a human beat the top chess-playing computer.
Yeah.
And that's interesting to me because it was very much a turning point in the field where much of the AI field had spent 50 years playing games. They're nice, they got clear rules, people have invested a lot of effort getting as good at them as possible. But that was kind of it. So since then, the only next major thing that happened was Go, which many people thought that computers might never exceed human players at Go. And it happened probably 15 or 20 years before we thought it would. And that's interesting to me because predictions almost always go the other way. It's always, you say 20 years and it never happens, or it happens in 40 years. But this is one where people thought we were 20 years away right up until in 2014. We found that Go was beat the top human grandmasters. So, the idea back in the day that chess was a hard game, like that made sense when I was growing up. Nowadays, if I talk to my kid and I'm like, my phone beats me at chess, they're like, well, of course, like it's got a computer in there.
Yeah.
So why wouldn't it beat you at chess? Like obviously computers are better than people at playing chess. And that's a fact of the universe now. It wasn't a fact of the universe, 25 years ago. So the fact that this keeps changing is one of the reasons I think that the field's exciting and is going to remain exciting, because the techniques that we use change, but they get subsumed into this same group of people in the same field working on whatever the leading edge is, whatever still surprises us that machines can do, that we expect to be solely the domain of humans. When we talk about machine learning is a specific technology. It's a technique that we use. There's a variety of techniques that fall within that umbrella. There's actually multiple ways to achieve artificial intelligence that don't use machine learning. And in fact, there are many ways to use machine learning that are not considered to be artificial intelligence. Yep. James is talking about controls, and this is a place where machine learning is very heavily used in controls in a lot of contexts that are no longer considered to be artificial intelligence. Like we don't think about HVAC systems as being intelligent, although virtually every HVAC system that gets installed has a machine learning algorithm in the thermostat, for instance. So these are two concepts. They kind of overlap, but not entirely. One of the things, again, I find very interesting about it is that these machine learning techniques are still broadly applicable. So we're in 3 different business lines. But we're all using techniques that we can sit around and geek out on and talk about the technologies.
Definitely.
We read the same papers. We read, we read the same documentation. Sure. And in that way, I think the field has developed, and it's looking more like something like a semiconductor engineer. That back in the day, if you were a semiconductor engineer, you might only work at a couple of different places. And then that started going to where there's more applications of it, more domains. And it's like now you need to have somebody doing PCB design for virtually anything that gets built, any consumer product that gets built anywhere in the world. And the same thing kind of happened. We used to have like companies that were robotics companies. I interviewed once upon a time at iRobot, and they made vacuum cleaners and bomb disposal robots. They don't anymore. They've split that business up. And what we've seen as this, as the field changes, is now it's kind of expected. It's like you can look at something. I think Boise Cascade's a great example. This is a business that you would think of as being in this day and age where it feels like America has moved away from like these manufacturing jobs of yesteryear. Like Boise Cascade's about what you think of. If you think of a big mill
Definitely.
with a bunch of trees coming in, somebody's sweeping the floors.
You got it.
Nobody has to sweep the floors during the day at Kount, right? But even in those applications, like you hire people like James, the technology, the skill set is being applied everywhere. And to me, that's the sign of the maturity of the field, that you don't have to anymore be in a specialized application saying, I'm going to go to a robotics company and build robots. You're saying, well, this is the skills that I have, and I'm going to go work sitting next to a software engineer, maybe sitting next to a mechanical engineer, electrical engineer,
Yeah,
and now it's interesting because the applications, like we can go after virtually anything out
right.
there.
Yeah.
Which wasn't the case in 2008 or it was really robotics focused, right, on those type of things. Now it's very expansive, so that's a good point.
Yeah.
Dan, what are your thoughts? You from all the things I like that Josh was talking about definition of AI. What are your thoughts about that?
For me, it's, we started off of, rules-based engines, right? So somebody that knew the system would create a rule and we'd run the data against a pretty static rule. And that was considered state-of-the-art. That was amazing. And then computing power increases, right? We had access to computers and, now if, Amazon, Google, whatever, you can, just add some more compute instances to this and run it. So the computing power goes up, it gives you more opportunity. And now you see that we're doing different models, and the models are learning and growing, and you're just programming stuff in and then letting the model learn some things. So it's gone from the point of, I've got a human that has to know all the rules, to, I think these things are interesting. I can create a reinforcement learning model that says, oh, okay, well, I've optimized this. When you start looking at the outcome, you're like, oh, okay, that makes sense. I didn't see that before. Or some of the other stuff where we're doing things with models now where the models are giving us insights onto our own business. That we used to be the subject matter experts, and now we're turning some of this over to the modeling and some descriptive analytics and things like that that are really kind of pushing our understanding of how things are related. Like James was talking about, well, this group didn't know what that group was doing. When you put an overarching AI system over top of that, you're like, hey, by the way, this person doing this over here is really having an adverse effect to this person over there. And you may not see it as a human. And I think that's where AI is really going, is being able to give us insights over broader areas, because the AI can take large amount of data that a single human can't just grok and figure out, okay, I see the patterns. It helps you come up with the patterns. I think that's where the future of AI is going to go.
Well, and what's really cool about what you're saying is it's a common thread here, right? That the expansive nature of what AI allows us to do. And so we're going to talk about, we'll get to you really quick, James. Talk about that on this whole definition thing. I think that, what are your thoughts about the definition and how it's changing right now within AI?
I think that these guys explained it very well, but I can say that in my work, the definition is definitely interpreted in a different way. Even some of the leadership in the plants, they're a little resistant to AI, right? It's Skynet, it's Terminator, right? And so a lot of my job is really not on the technical side. I wish it was, but I do a lot in explaining the value of the AI. And, I wanted to add to this, you were spot on in that, like if I'm in a plant and I'm trying to understand a machine, and, the old days we had, 100, inputs, and we would trend them, and you stack them up on top of each other, and that can get hard after 3 or 4, right? And imagine doing that with 100. You can't do it. It's impossible. But AI can do it, right? And so one of my favorites, and I'm going to get a little nerdy here, is PCA, right? I love dimensionality reduction because I can take 1,000 and cram them into just a couple, and then I can trend that. And so then I can identify these patterns that nobody else could see, but we can see them today.
Patterns are big in this, right? So how important is innovation in artificial intelligence development? Because what you were talking about this, Dan, Because I'm sitting there going,
It is.
what if you're sitting there and you try to hold on to old paradigms? I mean, it's going to be, things are changing, and they're going to change even more dramatically in the next 5 to 10 years, right? So how do we look into
Well,
this?
it's what Josh was saying earlier, is that we're reading papers, we're reading some of the same stuff. If you're not learning, if you're not out there reading the latest research, and you're not looking at where are things going, what things are now possible, you're falling way behind.
It's happening fast too.
And it's
super fast.
And looking at the papers coming out of some of the universities and some of the stuff that maybe we've tried 2 or 3 years ago, and we can't get a model. We can't pull the right text linkages out of this, or we can't get the model to do something. And then next thing you know, there's a paper. Oh yeah, this grad student has come up with a way of doing something novel with one of the neural networks or something, and it can now pick up that connection. If you're not reading the papers and you're not staying ahead, you're...
So if you could, talk about in your industries or what you guys watch, who are the most innovative people within AI, or what are the most innovative companies? What do you think, Josh?
Tesla.
I'm going to let these guys think about that. And I'm gonna just say about the how fast things move.
Yeah.
It's amazing to me. There's things I learned when I was in school, and then I went out into the industry. And I think everybody has this experience with going through college. You're learning the newest things, but you don't realize it. So I went out, and then I learned new stuff, and I'm like, oh, I guess they were teaching me old stuff in school. And then 5 or 10 years in, I started seeing things pop back up again, and people were like, hey, I heard about this new thing. And I'm like, okay, I got a whole class on that. I just didn't realize that was the new thing out here. And maybe it just took me a while to figure that out. But that, for me, the first part of my career was experienced that way. It was experienced as industry catching up to where we were in academia. But I feel like that has really changed in the last 5 to 10 years. So the example I'll use is natural language processing, NLP, which is probably the fastest advancing field we have right now in machine learning and artificial intelligence. And it's a blind spot for me. It wasn't really much of a thing. Like, we were doing speech recognition and synthetic speech and things like that when I was in school. So now we're getting to all of this actual understanding, not just, can I transcribe what was written, but can I understand the concepts or the sentiment analysis, be able to do recommendations, things like that. And, I think a lot of what, what Dan's talking about. So I told myself about 4 years ago, I'm like, I'm going to go learn about NLP because I need to know about this. And I literally, 4 years, I'm not exaggerating this. And at the time, the state of the art 4 years ago was recurrent neural networks. It was long-term, short-term memory. Yeah. And I'm like, well, that's what I got to learn about. And then a year later, I sat in on Casey Kennington's class for a lecture over at Boise State. And he was talking about how you don't need to know this stuff anymore because it's all turned and it's all going in a different direction. And it was GPT-3. And so then I'm like, okay, well, I don't have to go. Glad I didn't waste that time learning about neural networks. Now I need to learn about GPT-3, whatever that is. And then a year later, BERT comes out, and it's like GPT-3 is just in the dustbin. Nobody even touches it anymore. And I don't know, I'm probably a year out of date, but there's probably been something new that's come out in the last year because I still haven't gotten around to this. And so the entire field has completely changed. These aren't minor modifications to how it works. This is everybody completely is changing their approaches. And it's moving so much faster from academia into industry that this isn't just interesting, again, in an academic context, but this is companies that do this for a living, people that are doing things like document analysis. When you have a lawsuit, most of what you're paying for is document analysis. You've got just this huge amount of discovery that you have to go through. There's a lot of money to be made there, and people are pulling these technologies as fast as they're coming out of academia. They're pulling them right into business and applying them. And it also has led to, it's been synergistic with the migration of people. The fact that whereas many fields train PhDs to go and become professors, our field has been training a lot of PhDs doing this real research, and then they're immediately able to turn around and apply it. And I've spent a lot of time in academia. It's rare to find a field where anybody cares what your PhD topic was. But in our field, we actually do, because it's straightforward for somebody to go research something brand new and then go turn around and actually directly apply it. Not take 10 steps backwards and do something remedial, but apply it.
But the interesting thing that's going on here is the continuous learning that you're going through, right? Because you're in the PhD program over at Boise State in the computer science program, right?
I am.
Have you graduated almost, or you almost?
No.
You're not, okay.
I've got a paper in review right now,
Okay,
and
so-
I'm really waiting for it to get
So
to get
please
done.
reach out to your principal investigator and let them know how important Josh is to this. No, and I would say that that's one of the big things that's going on here, you guys, is that as I hear it, and then if you talk about what you do, James, you were talking about how you're continuing going. You just completed your master's?
I'm still, well, I've got about 6 months left.
6 months left on it?
Yep.
And I think it's important to build
I didn't
understanding.
figure we were going to get beat up this hard.
I know, my God. I was like, wait a second, I thought we were.
Okay, I finished my master's in December.
Showing my
so
grades.
In December?
I'm good. I'm good.
Well, see, there's a little bit more gray hair on that goatee,
done, I'm
right?
done.
Let's hear it for Dan. Yeah.
We're going to need some advice on how to get this thing over the finish line.
Okay, with the gray hair, it's taken me a while. I mean, I had a lot of people say to me, "Why are you going back to school for a master's degree?" Because things are changing, and I wanted to be more advanced, and the data science stuff is just so interesting that I felt that getting a master's degree would really help. And one of the things that, if you're in this industry, there's one skill that you really need: to be able to teach yourself, to be able to go, oh, here's an academic paper, I'm reading it, oh, I don't even know half of these words.
Yeah.
Nobody's experienced that, right?
Oh, I've been there.
Right? So,
I steal
so
them
it's
there.
go learn a new language, and then try to understand the paper, and then try to put it into use. If you have that skill, not just for data science, I mean, that'd be amazing for any skill, but you really need that type of skill in data science, because let's say that we're looking at a new NLP. We want to be able to bring in a new type of document, and we're running into some problems. I need to go out and take a look at the latest NLP research to see if there's something out there that may help me solve my problem. And it's not just, you're looking for anywhere, because if you focus on a couple of, the question on influencers, right?
Yes.
If you focus on a couple of influencers, it's not enough. Because, because that guy in the University of Bangalore had this really cool paper, and that's the piece you needed. Well, I'm focusing on Carnegie Mellon because Josh said Carnegie Mellon's it, and I was doing that, right? Well, no, it could be some obscure paper, a PhD paper out of some minor college that somebody stumbled onto the piece that you needed to solve your problem. So it's more breadth of being able to go find the papers that you're looking for is more important in my opinion.
Yeah, and we get to do this even in industry. And I think that's the most exciting part, is academic quality research in industry that we then get to commercialize. The thing that I regret most about my time at Kount is that we came up with a technique that was extremely valuable for us. It worked really well. And we decided to maintain it as a trade secret instead of patenting it. And a year later, that technique was published at NeurIPS, which is the biggest machine learning conference that there is out there. And now it's like it's standard. If you look at Kaggle, like a year or two after that, it was like every Kaggle competition was won with this technique. And I could have gotten a lot of papers out of that. I could have gotten a lot of those things there, but we decided not to. And it's like there are probably, that's one that picked up out there. But there are things that people are solving in just the day-to-day, like how do we solve this problem, where you're getting to operate at that level. And not all of it gets published out of industry, oftentimes just because we don't have the time or because we don't realize that what we're doing, like I actually thought that this was kind of a simple, like once you figured it out, it was pretty straightforward and simple. I wasn't sure that it was worth going out and talking about.
But it was very innovative, right? I mean, that's the part that goes on here is
it worked really well.
Yeah. The vast majority of new products and services and R&D that's commercialized comes out of industry. So if you take a look at that, I mean, that's how important this is for us to continue to develop these type of things. James, you had something you want to say?
Yeah, and so, I'm going to college, and that's great. But I'll tell you, with the internet and the way things are today, you can learn all this online, or the majority of it. I'm not saying all of it, but if you have tenacity and you are self-taught, it's out there. You got to put in the time. And again, I'm working on my master's, but as I'm going through the program and I see what's available online, especially today, anybody that wants to get into this today, you can do it. You can do it right now. Just start.
Yeah,
and you can know more about transformers than I do by just watching a few hours, because I haven't gotten around to it yet.
Yeah, it's all out there.
And this is actually one of the few industries where you don't have to have a master's degree in data science.
Nope.
The number of people that, it seems physics is a really good, I couldn't do anything with physics, so I decided to do data science instead. But there's so many data scientists that are out there that they don't have a data science degree. They have an engineering degree, which means that they can, if you've gone through an engineering degree, you have to be able to learn and teach yourself at some level, and have taught themselves data science. And it's valuable.
That's a great point. It's a great point. Okay, so this is interesting, because if you're looking right now in the self-taught things that you're just referencing, who are some of the leaders from an industry standpoint that you would follow? And where you're learning stuff? I mean, because I liked how you're saying, maybe I might go to Bangalore and have somebody that I don't got to go to Carnegie Mellon, but Carnegie Mellon was really good at this one spot, but there's something else that I need to find out that might be a blind spot here or something like that. Who are the ones that are leaders in this industry right now?
Yeah, so I can speak for me. I don't have a specific one now, although I do like Tesla, and I think they've got a really good plan. But there are so many platforms online. Just like Medium, is an example. I can go on and on, but just on the YouTube platform alone, there are so many examples of great examples of people that are teaching this.
Yeah, and I think I spend more time probably listening to people who are not actually driving the research, because as anybody who's gone to college knows, doers and teachers are not necessarily the same thing.
Right.
So one of the other nice things about how this is developed is that a lot of these platforms, I mean, Medium, YouTube, et cetera, there's a lot of people out there who you can go read the original paper and not make much sense of it.
Yep.
But there's a lot of folks that are really good at explaining, that are looking at the things that are coming out and are converting it into a much more accessible mode. I think, to the point of like, basically, do you need to go to college to learn this stuff? I think that the benefit that you get from a structured university program is it forces you to get a certain amount of depth. There's been thought put into what things are important that you should know, and that are a little bit more timeless, so that you're getting the math and the techniques and some of those things. But again, you're not going to get the newest and the greatest stuff that's coming. So I really do like both of them. Yeah. You have to get you don't have to get the degree, but I think if you get the degree, that helps a lot with the foundation. But you got to realize it's not going to be sufficient.
Yeah. You mean we have to know math for this too?
Yeah. Well, you don't have to.
Yeah.
You don't have to. This is kind of one of the fun things. He's trolling this, because if you go online and you read about this is one of the things that people love to argue about is how much math you really need to know. But for me, I would always prefer to know more than I need than less than I need.
That's interesting. I like that. So how, you have all this stuff like Clayton Christensen talks about innovative disruption, and how you're always trying to figure out how you can meet customers' demands today, but more importantly, how you can meet them into the future. So if you take a look at AI, how's that helping your companies come up with new solutions to be able to meet customer demand?
In the financial industry, everybody's looking for those insights that get you a little more alpha, a little more return on your money. And so the more you advance, right, the more you can look at broad swaths of the financial markets and be able to pull data out of that to provide insights to a client. That's where AI is really pushing. There's even an entire field, the quants part of finance. There's folks with PhDs in mathematics and data science, and I mean there's huge teams of PhDs that are just looking at how can I drive the insights, how can I look at all of this data holistically and pull out patterns or trends to help my investment firm make a little bit more money. And
And that's probably going to be a differentiator for Clearwater Analytics in the future, right? Or if you don't make that, then some other company will disrupt you.
Exactly.
Yeah.
And so if you're not looking at where our clients need us to go in the future and what can we do to position ourselves, like in any business, you're going to get disrupted.
That's good. James?
Yeah, so, my mind goes to two things here. Our company is really based on the housing market and commodity prices. And so some of the stuff that we're doing today in the background is now we're able to predict that in a very accurate way. And so that is driving business decision to help customers buy the stuff at the right time, right? And then in my work where it's in the plants, because we're applying these algos that can handle all these inputs, we're able to take the variation in our product and squeeze it. And so because of that, the quality improves, right? And I've seen that with my own eyes. And so now we're delivering a better quality product to our customers. Now, a lot of times they may not realize it, but I see it, right? And so those are two areas I think.
I love what you always said. The thing that you said the very first is that you talked about how the quality of the product is so important, and then safety are the two big things, right? But you keep those things in the parameters, and then you can kind of, you build on.
Let it go. Let it go. That's right.
Yeah, my theory about automation, because that's usually how I like to think about this. Again, artificial intelligence is a characteristic of a machine. Machine learning is these techniques, but the business value that we deliver is automation. And I stole this paradigm from robotics, because robotics is another thing we love to have arguments about what constitutes a robot, what the definition should be. The definition I've always liked is it perceives the world, it thinks, so it has to be more than just a stimulus response, and then it acts. It has some way to go back and influence the world. And when I worked in self-driving cars, the biggest problem we saw for adoption back then was how you were ever going to afford to put all of the sensors and all of the actuators on the vehicles. Right. Software, we didn't have that problem solved either, but at least that you kind of understood Moore's Law, we'll get it solved, the compute will get better. But the sensors and the actuators won't. What happened is that nowadays you buy a car and it actually, it has actuators on it. Most cars are shift by wire, most cars are gas by wire. Regenerative braking on electric vehicles, and steering assist on cars now. And I think that's where you see the increase in the applicability for things like in manufacturing. So if you were trying to sell, hey, let me go into a lumber mill 40 years ago, and I'm going to find these efficiencies, you'd never get there because it's like, well, step one, we have to go buy all this extremely expensive computer-controlled machinery to do all of this. But you've already made that investment. So there's like this installed base out there that means you can go and you can apply to it. And I see the same thing as like Kount wouldn't be in business without e-commerce. So the fact that there is this opportunity, because we can go, for us, we affect the world through, whether we let you buy something or not. Yeah. So that's the mechanism. And only because there's all of this e-commerce ecosystem out there does that give us that opportunity. And then you go look at the data. We have to have places to go and collect all of this data. And I think, looking at like Clearwater, that's from where I sit on the outside, that's the whole Clearwater business model, is people know theoretically what the basis of the value of derivatives are, but do you know for all of your portfolio what is supporting the value of that of those products? And a person could go through and could trace one thing all the way through, but to be able to do all of them all of the time quickly, that's the advantage. And really where nobody wants to be in the business. We're not trying to replace people who are making $15 an hour doing, for me, fraud analysis.
Yeah.
We are, if that was our goal, we wouldn't be valued the way that we're valued as a tech business. So, for us now, the questions are all like, what could we do that people couldn't even imagine before?
I agree.
And I would imagine that's the deal in lumber. It's the
same way.
It's like, how much you're getting out of a log, that you're getting more out of that log because of the techniques that you have are bringing all your tolerances down, and you can enforce that quality. Yeah. And again, for us, we're making decisions in under 250 milliseconds. A person can't do that. So the value now, we used to joke when I was working self-driving cars, we'd joke that you could tell that it was a self-driving vehicle because there were 20 grad students around it, keeping it running.
Yeah.
And this is a real thing. We have predators now. A predator firing a Hellfire missile is an unmanned vehicle, but there's 3 operators for a predator. There's 1 operator for an F-16, which is what it's replacing. It's not to say that there's not value in that, but actually we oftentimes see that this automation, it leverages the human component. And one of the things I realized is I'm like a human factors expert. And I got there by being an unmanned systems guy. And all we ever worked with was, how are you going to interact with this? Look at self-driving cars today. So many of the questions are about how, if you're going to do handoff, which is its own can of worms, how are you going to do that? How do you make sure that you're communicating what the car is doing back to the person? So there's this huge, human element to it, and really, like, I think all the opportunities that people are going after right now to go to your point of Clayton Christensen and looking for where where those disruptive opportunities are, is there something that we can do that you can just barely do, right? The definition of disruptive innovation, something that's a low-featured, just barely meets the bottom of the market. Because if we can get that automated, then pretty soon we're going to be doing, we're going to be going up market, and we're going to be doing things that where we could only do it marginally before, we're going to be able to do it for everybody right now. And those are, again, it's not going and replacing people's jobs one by one. Yeah. It's about, like, what can you even accomplish today that you couldn't accomplish yesterday because human in the loop was just too slow or just didn't have access to enough data.
So it's interesting. You have the human in the loop is an important one, how you can help human interaction. And then the other part is how you can optimize human thought that you could accelerate everything which you guys have done. So I want to do this. I'm going to open up to the audience. I want to see if we can get a couple questions. So as you guys think about the question that you think is a burning question, the fun thing that's going on with Josh is that we had a deal several years ago, about 4 years ago, where we brought Sterling Anderson, who is from Aurora, one of the top autonomous driving vehicle experts, PhD from MIT, grew up out by Burley, and from Idaho, and this was one of the top people in the world, really. And he's been doing some amazing things. And Josh came and ran a deal, but I want to tell you that because this is what having individual thought leadership comes because of the people that are experts and expansive in that field, like you've been talking about, Dan, as well. But any questions you'd have from the audience that you'd like to ask from our AI expert panel? Yes.
What are your thoughts on privacy and speech recognition technology? Example, a couple days ago, I was talking with my wife about what we're going to do to the floor in our bathroom for remodeling. Within 10 minutes, we have a phone call on her phone. Yeah. Somebody asking how to take
James, I want to hear your grandmother's view of this.
Yeah, I want to hear.
Yeah, that's a good one.
Is that the devil?
That's it. No.
So
it happens.
So the question is, again, about voice recognition, like when you sit there, if you have it on Google or...
There's always been concern about privacy, and especially with the speech recognition stuff, because, phones are getting more powerful, but it behooves whoever's doing the speech recognition to send it up to the cloud. Now, I think you're going to see out of the government some regulation about what they can do with the data that we're sending them to translate, because it is getting to be a hot topic, just like you said. It seems that you're not the only one that has noticed that if my wife says something about purple shoes and I get my next thing I know, I'm getting ads popping up on everything, oh, buy these purple shoes at Amazon. How did that happen, right? And so there's a lot of concern, and I'm expecting that the tech companies that are doing this, they're selling the data to the advertisers, are not going to want to change. But I think people are concerned about being monitored, and it's going to have to be some government regulation forcing them to change the way they do business.
Any other thoughts?
You know, I don't have a strong opinion on it, but I will say, you know, these things right here has got a ton of AI in them, right? And so this has more capability of today than a lot of the machines do in my plant, right? So you're spot on in recognizing that. Yeah.
Yeah, I do have strong opinions about this. I'm kind of a privacy nut. You know, I work for the most regulated data company in the world, and which I'm reminded of every day, some way or another. And I think this is, you know, you're talking about the tech companies. I think it's important for us to recognize that, like Google and Facebook, I mean, they are tech companies, but they are advertising companies, right? So that is their business line. That is what they do. And you know, just me speaking as an individual, as I look at what's coming, I don't think that they want to be. I don't think they want to be in our houses. I don't think they want to be running identity for us. So I think you're going to see that there's parts of that they want to divest because they don't want to have to be, you know, experts in these regulatory environments, and to continue to run afoul in the you know, in the marketplace out there where they do things that make us as consumers, you know, very, very upset. So interesting things for me that I think the field is dealing with right now are questions of consent, how we can manage our own data and create those opportunities. I've seen it happen in e-commerce where, you know, we at Kount, like, part of what we do through the transaction is we see the device that you're coming from, and that's part of how we know if it's you coming back again or if it's somebody else. Yeah. And for a while, everybody was browsing in incognito mode, and that makes it very hard. You don't get cookie tracking, so it makes it very hard to recognize devices. And we thought that was existential. Like, we're going to lose this ability. Well, I don't know about any of you, but, like, again, even as a privacy nut, I don't use incognito mode when I'm buying stuff anymore e-commerce because the experience is so terrible. So even somebody like me who's going to say, don't track me anywhere, don't know anything about me, don't do any of that stuff, if I'm actually going and I'm doing e-commerce with a company that I know, I'll get out of incognito mode because I'll be like, oh, whoops, I forgot, because of that experience. And we've seen that as the behavior has changed. So I really do think that the important thing, the exciting thing moving forward is going to be about consent, how you manage and maintain the data that is kept, because it's your data. You should be in control of it. But we don't have these mechanisms right now to be able to do this.
And shortly after that, I had my wife turn off her VPN.
Mute. This, by the way, before COVID hit, I was at a national public policy conference in California, and privacy was the biggest issue, right? Everything we're talking about right here. Then COVID kind of came, and but I think it's still the major issue in the United States right now, from a policy standpoint. We have time for one more question if there's one. It's burning. Yes, let's go right here to John, and then we can. Let's talk. Let's see about right here. If you two can take it, and then we maybe have a time for one more question.
Yeah. We frequently sit down with subject matter experts and do some brainstorming on where do we think we can go. Yeah. It's very important. I mean, it's ideation sessions. Where can we go with this? Where can we take this? Innovation is important. We schedule time for it.
Yeah, so for me, that's actually my job, right? If you look at the title here, so I travel around all the plants and I talk to all the leadership, and so I try to share what I'm learning from everywhere else with everybody, and through that, I'm collecting everybody's ideas and everybody's opinions, and so my main job is to collect it all and then share it with everybody.
Yeah, the question, again, I didn't say it was about how we get more ideas to be able to find solutions and things, so I think that's great. One last question. Let's go right here.
As much as the AI is exciting for me, it is scaring me.
Yeah.
As an AI in the cybersecurity, like voice recognition, is it any way AI can stand to the AI and using AI against the cybersecurity?
Josh, want to repeat the question?
Yeah, so I think the question is around AI is exciting, but it's also scary, and how can we keep it from doing bad things to us because we're creating all this capability. I think that if you look at, if you talk to experts in the field, we're generally not very impressed with the stuff that we're building. So there's just very little concern from specialists. I hear people say, oh, well, Stephen Hawking said, well, Elon Musk said, and I would say those are two very smart guys. You know, they're not artificial intelligence experts. So that's the first thing, is I think that, you know, none of us are worried about runaway intelligence in humans. That's not like the biggest concern that we have out there. And that's a lot of the same way that I feel all of our advances in artificial intelligence have been with great difficulty, and we've never reached anything that starts to look like a singularity where all of a sudden things start getting easier. But that's the technical side. I think, you know, there is still obviously a lot of danger. I live in a cat and mouse game. I fight fraudsters. They use tools and techniques against me that I'm using against them. And, you know, and it is cat and mouse. You see the advancements on both sides, and the job is harder now than it used to be, which is fine, because it just means that I'm still in business. I don't want it to ever get too easy. And I think, you know, we were talking before this started about deep fakes, and I think that that's one of the places where we're starting to see this, this come out. And again, like being kind of a privacy nut kind of a guy, I feel like these are new techniques that we're seeing, but it's not new problems, right? There have always been problems with fake news, with synthetic content. As people, we're just going to start learning that it doesn't mean anything to say, oh, no, I saw the video. Like, that's how we say it now. You're like, I heard a story, and I'm like, yeah, that didn't happen, right? And now, you know, but if you see a video of something, you've thought like, oh no, I guess that really did happen. But I think that's just what we're learning. You're seeing this in Ukraine. There's video game footage that looks realistic that's coming out of things happening. And then somebody in the comments on YouTube points out, oh, guys, this is a video game. You look back at it and you're like, oh yeah, I guess it is. So we're gonna learn that where I don't think we'll trust it as the same way. But there's definitely a lag where it's a little scary.
Josh, I think that what's going to be, we're out of time right now, but I will say this, that the scariness of artificial intelligence, I believe, and I'm sure you guys would agree, it's going to amplify, because as you use the good guys that are doing it, they're going to have bad guys that are going to amplify it out on all of this too. So we got to make sure we stay on top of this. But the main thing is, I want to make sure I thank Josh, Dan, and James for taking time to be able to come and talk about artificial intelligence, how it impacts our company, and the positive nature that is taking place with your companies. Let's hear it for all three of these.
Thank you.
Thank you so much. Thanks so much.